Alright, good day once again. It is Shala Michael, and welcome once again to Success Enlightenment. This is an Econometrics series. Alright, today on Econometrics series, we'll be going into the ordinary least square estimation of the of our econometrics estimation. That is talking about how we estimate our regression analysis. We'll be dealing majorly using the ordinary least square estimation. All right, how do we estimate our econometrics parameter? Okay, suppose we're given a simple linear regression. We're focusing on simple linear regression in this video. We're talking about simple linear regression. We're talking about a regression analysis that is linear. Because simple linear means there is no power, it's not exponent. When you have something like this, y equals to, let's say, a plus b raised to power x. Alright, this is linear. Why? When you ask like y equals to a plus b raised to power x raised to power 2, this is not linear. This is not linear because this is raised to power more than 1. When the independent variable is raised to more than 1, it is non-linear. Alright, when you have something like this, y equals to a plus b raised to power x plus a plus bx plus c q. Okay, let's use p. Alright, here you are having more than one independent variable. This is multiple regression analysis because you have more than one independent variable. But here in this video, we'll be focusing on simple linear regression analysis. Alright, simple linear regression analysis. Alright, when we talk of simple linear regression analysis, alright, we're looking at this. Alright, we have y equals to alpha plus beta x plus our error terms. Alright, here we have y. This is capital letter y, this is our capital letter x. Our capital letter y here stands for what we call the dependent variable. Alright, the dependent variable. Right, this is also called what? The variable that we are trying to study. For instance, let's say we're making analysis on the quantity supply. Let's use quantity supply. Alright, this is the independent variable, which will be in this illustration will be the price. We already have the understanding that the quantity supply of a commodity is a function of the price. Okay, this is an econometrics model, and that's why you have the stochastic terms, which is the error times. This is our error times, these are error times. You can label this as 1. These are dependent variable. This is the intercept. This is the slope. This is the independent variable, and this is the residual or error term. Alright, this is the residual or error terms. Okay, don't worry, in a video we've already explained what each and every one of these means. Alright, let's say this is a supply curve. You have something like this. Don't forget, you know how supply is drawn. This is your price, and this is your what? Quantity supply. And your supply curve it doesn't start from the origin, because here we have an intercept. Our intercept here will be what? Will be alpha. Okay, it will be alpha. Since it is have to be estimated, this will be alpha cap. When you see cap, see this is just alpha. Now when you see cap on top of the alpha, right, what it means is what is alpha estimated. Don't forget, your alpha is your intercept. So when you see cap there, it means the intercept estimated. Estimated means the value you derive from your what? From your solutions. Okay, You can use econometric software to just do this. You can use eView right away. But here, we're talking of how you can solve it using your hands and a formula that will be derived in this video and subsequent word video. All right. This is the slope. Don't forget. Slope is also the same thing as the word as the gradient. All right. Also the same thing as the word gradient changing y by changing s. Don't forget you are taught that in your mathematics for economics 1. And this definitely is the word independent word variable s, which is the word your price, and your error times is now, you know, in econometrics we deal with empirical word analysis of what economic word phenomena. That is, we collect what data, right? Your data usually could be time series data, it could be panel data. Irrespective of the type of data you use, you collect real life data as to what is happening in your society, in your environment, right? So when you collect this data and you plot this data, this is normal curve you have, but you can realize that your data could be like this, could be like this, could have something like this. So the gap, you see, this is the normal line you have, and this is the normal hypothesis you have, but this is the actual observable data. So the gap, the space between this and this is what is error times. So is your error times. These are the residuals. All right. What the error times really capture in econometrics analysis is that it shows that if this is the quantity demanded, quantity supply, and this is the price, and we have the error times here carries all other factors that affect the quantity supply except the price, right? We already know in our basic econometry, basic economic theory that it is not only the price of the commodity that affect the quantity of the commodity that is supplied in the market. We already know that as a fact. So there are other factors, right, that affect it, the quantity supplied, such as the cost of production, such as the populations, right, that affect the what, the prices of the what, of the commodity. So, but in our model, don't worry, model is a simplification of the reality, right? We simplify, that is, we focus our attention on the particular aspects that we really want to study. We simplify it, we take some irrelevancies out of it. They are relevant, but for our studies, it's not relevant for now. So now this our error time, which is the stochastic time, the residual value here, captures all other factors that affect the dependent variable that is not captured in this independent variable. That is what the error times, that's what is what it captures. Alright, I believe this is well understood. Now, when we have this now, how do we estimate our econometrics model? This is an econometrics model, it's not a mathematical model, alright? Because we already have an error time. So when you have a deterministic or a mathematical model and you have an error time attached to it, it is an econometrics model. Without an error times, you are not dealing with an econometrics model. And this is a simple linear econometrics model, and we want to know how do we estimate this model. Right, let's get right to it. We're using what? Ordinary least square to find our estimate. There are two approaches there. You have the absolute approach, you have the deviation approach. But in this video, we're dealing with the what? The absolute approach. Alright? We're dealing with absolute approach. We have the what? The deviation approach. Alright, the difference between this and this is simply because that in the absolute approach, what you are dealing with is what? Is your capital letter Y and what? Capital letter X. While in the deviation approach, what you'll be dealing with is what? The small letter X and small letter Y. You already know the distinction between capital letter Y, capital letter X, and small letter S and small letter Y. Right? From our knowledge of statistics, our small letter X will be what? Capital letter X minus S bar. Why our small letter Y will be what? Capital letter Y minus what? Capital letter Y bar. Where S bar equals what? Summation X over N, and Y bar equals to what? Summation Y over N. So without verbosity, let's go into what? How do we what? Estimate a simple linear regression using what? Our absolute approach. Let's go right into it. Welcome again. This is Success Enlightenment, and I remain my humble self, Ishola Adedeji Michael. Let's get into the business of the day. Alright, this is the business of the day. Now we have our basic econometrics model here. Y equals to what? Alpha plus beta x plus u. Alright, let's call this equation 1. Don't forget we're dealing with what? Absolute approach here. Alright, let's call this equation 1. Now we want to find the what to be our what? Our y estimate. That is estimate of this what? Model. Don't forget in econometrics we are trying to find an estimate, attach number to the parameters. The parameters here are the alpha and the beta, with our alpha being the intercept and your beta here being the slope. Alright? So now your y cap, which is the y estimate, we give you alpha cap plus what? Beta cap x. Let's call this what? Equation 2. Now when you observe this, there's no more error times in it. Alright? The error times is no longer here because we've already estimated it and error times is already taken care of in the estimation. And that's why, furthermore, when we make our economic analysis, we further find what we call the word R square. Alright? Don't forget, don't bother about that now. Alright? When we get there, we explain what is what R square. R square means coefficient of determination, by the way. When we get here, we explain what that means. But for now, let us climb the steps one at a time. Okay, so this is your y estimate. This is when you see cap, when you see this sign, it means estimate. Right? Estimate, and you're dealing with what? Figure. Right? When you apply your formula in solving this is what you get. Right? So now from here and here, you can see that this is your y. Right? This is our y. You can say this is our y, which is capital letter y, is the same thing as what? This y cap plus u. Because when you look at it here, right, dealing with this y, right? Well, the error times has been taken out of it. Okay? So when you put this back to a correct model, you are putting the what? This u back there. Okay? This u, don't forget, it covers every other variable, every other factors that have the power to influence or that have an impact in the dependent variable that is not captured in the model that you are studying. Okay, so this is what this is. This is the estimate plus the error times back, and that's give us our y, because there you see the error times is the only thing that is not there. But when you look at the ordinary least square that we are using, ordinary least square OLS, and the primary objective of the OLS is to minimize sum of square error. That is to minimize the word sum of square error or sum of square residual. As is, you are dealing majorly with this word, with the error times in the word, in the ordinary least square method. Okay, so in that way, that means we can definitely put what we are to find to make this error times subject of the formula. Okay, we have to make this subject of the formula. So let's call this first equation 3. So make the error term subject of the formula in equation 3. So therefore u will then be equals to what? Y minus what? Y cap. Okay, now don't forget equals to y minus what? Y cap. You already know what your y cap is, right? Don't forget y cap is y estimate, and it's the same thing as what we have in equation 2. So what you simply do here is you substitute this for here. You substitute this for here. So therefore, when you substitute equation 2, let's call this equation 4. So substitute equation 2 in equation 4. So your error time then equals to what? Y minus into bracket. That's y cap plus beta cap x. Okay, so and this you can write this as u error times equals to what? Y minus what? Y cap minus what? Beta cap capital letter S. You can name this what equation 1, 2, 3, 4. You can name this equation 5. Alright, this is your error terms. Alright, this is your error term. This is the same thing as what? This equation 4 and 5, they are equal, they are the same thing. So from here now, all you have to do is now do the ordinary least square, which is what? Find the what? Minimize the sum of the square error. Okay, you have to minimize the sum of the square error. First thing you have to find is what really is the sum of the square error. Then when you find what is the sum of the square error, then you can then minimize the sum of the square error. So let's quickly get back to it. Let's find what is our what? Sum of square error. Okay. So this is our equation 5, which is the word the error time. So what is sum of the square error? So from here you say take sum of the square of the error time. That is sum error time square. Okay, summation of the error time square, which will then be, don't forget, this is your error times. This will now be what? Summation into what? Y, capital Y, minus alpha estimate minus what? Beta estimate x square. Right? It's as simple as that. This is sum of your what? Error terms. Alright? This is sum of the square of the error terms. This is the square and this is the what? Sum. Don't forget, in ordinary least square, what we are attempting to do is to what? Is to find is to minimize the sum of the square error terms. And that's why ordinary least square is very, very, very useful in econometrics. In fact, it is the most widely used method in econometrics analysis because it gives the least variance compared to all other methods of what? Econometrics analysis. Because in ordinary least square, the motive is to minimize sum of the square error terms. Right? That's which automatically transfer to what? Having the minimum what? Variance of all the method of what? Econometrics analysis. Alright, so from here what we do is you minimize this. Now if you recall from your mathematical for economics, on the level 20 level studies for economics, when you are minimizing or maximizing a function, then you are applying what? Knowledge of what? Derivatives. Right? You apply you apply knowledge of what? Derivative, that is what? Differential calculus. So from here to minimize this, what you do is what? Is you take first you take the what? Take the partial, call this equation 6, partial derivative of equation 6 with respect to alpha, cap, okay, alpha cap, and equate it to 0. Okay, so the first thing to do to minimize sum of the square error time is you take the word, the first partial derivative of equation 6, which is this, with respect to alpha cap, and equate it to 0. Let's quickly do that. This will be equals to what? Derivative of summation u square error square with respect to what? Alpha cap. Right? Now we are finding derivative of this with respect to what? Alpha cap. Now don't forget, this you have here is a function of a function. That's what you have there. So which means you are applying what? Change rule. You are applying change rule, which gives you that, for instance, you are having y equals to what? S plus 1 raised to power 2. Okay, this is a sample function of a function. All you have to do is what? You let s plus 1 equals to u, therefore your y equals to u squared. So therefore now the y dx equals to what? The y du times what? The u dx. That's function of a function. Okay, that's function of a function. So in this our illustration here, but in this our illustration here, so to estimate this using chain rule, uh you let u will then be equals to what, y minus what, alpha cap plus what, beta cap x. Okay, so therefore the first your y then will then be equals to what, u square. So the derivative of u square will give you what, 2u, 2 minus 1, isn't it, as what, 2u. Okay, right. Don't forget what your u is, which is what, y minus alpha minus beta cap. So therefore what you have here is 2 summation bracket y minus alpha cap minus what, beta cap x. All right, so now the next one you are using is what, the this du, this is y du. So now you are find du the alpha, right? Du the alpha, that is the derivative of this with respect to alpha. So this is why there's no alpha there. So the derivative of a constant is equals to what, 0. This will be 0. Here you have alpha. See, this alpha raised to power 1. So the derivative of alpha raised to power 1 will be what, 1. This will be what, minus 1. Here there's no alpha there, so this is also a constant, which is 0. So du the alpha cap rather equals to what, minus 1. So you have what, minus 1 here. Okay, now don't forget you have to take the first partial derivative of equation 6 with respect to alpha cap and equate it to what, to 0. So this will now be equals to what, 0. Do we get that? This now equals to what, 0. So now from here we can further simplify this. Those. How do we simplify this? And the first thing, we can take this minus out, so we can have this equals to what, minus 2 summation into bracket what, y minus alpha cap minus what, beta cap x into 1 equals to what, 0. All right. The next thing we can do is what, we can take this minus 2 out by dividing all through by what, minus 2. So simply we divide through by minus 2. So therefore we have minus 2 summation y, summation into y, alpha cap minus beta cap x, 1 equals to 0. This divided by minus 2, this divided by minus 2. X divided by 0 definitely equals to what, 0. This take this out, so we have summation y into bracket what, minus alpha cap minus beta cap x into 1. So 1 multiplied by everything here is same thing as what, everything here. So simply the 1 is still what is repeated. So therefore, so let's take this summation out and see what we have. So summation times y, we have what, summation y. All right, summation times alpha cap. No, don't forget, in our basic econometrics proving, we already established that when you have a summation times a constant, so what you have is not the summation of that constant, but instead what you have is what, the n that constant, that is n times that constant. So therefore this will be what, minus n alpha cap, right? Why this will be what, minus what, beta cap summation x, which will now be equals to what, 0. So from here now we can take y to be subject of the formula. Okay, and take y to be subject of the formula. If you take y to be subject of the formula here, make y subject of the formula. So therefore what you have left to be what, will now be what, summation y equals to what, n alpha cap minus n alpha cap, this turn to plus, all right, this minus a turn to plus, this will turn to plus, this will be plus beta cap summation x, beta cap summation x. All right, this we call this what? Equation 7. Call this equation 7. Equation 7. Alright? These are simple as this. What you find there is equation 7. We call this what? A normal equation. Right? When you are dealing with the ordinary equation, you are going to get two normal equations, and of them, this is the first normal equation. This is the first normal equation. Now, well, how do you find the second normal equation? Don't forget, the first normal equation, we get it by finding the what? The first partial derivative of our sum of square error with respect to what? Alpha cap. Now, the second one we are going to find by finding the first partial derivative of our sum of square error with respect to what? Beta cap. Beta cap is same thing as beta estimate. Alpha cap is same thing as what? Alpha estimate. So let's get right into it, and let's find our second normal equation. So to find our second normal equation, what we simply do from here is what? Is we take the first partial derivative of equation 6 with respect to beta estimate, and we equate it to 0. Alright? And we equate it to 0. So from here now, what do? We have first partial derivative of what? Sum of square error with respect to what? Beta cap. Now, I've already explained how you do this using what? Chains rule. So to save our time, I'll just go right to it and tell you the answer. You can apply your chains rule. If you've forgotten it, this is the best time to what? To revise it. So it's something you must know. That's why you are taught, right? Our knowledge is sequential. You cannot jump gap, right? So what you've learned in your previous classes, they are important keys for you to understand your higher classes. Okay, so this will be what? Will be 2 summation what? Y minus what? Alpha cap minus what? Beta cap x now minus what? X equals to what? 0. Alright? Equals to 0. Just master your chains rule. I've already explained it in the first one, so it's very, very simple. I believe all of you even understand that. Alright, if you don't do, feel free, you can DM me. Alright, personally, I will explain that to you. Very, very simple, but take your time. Don't just, so that enlightenment is there. No, do your due diligence. Alright, do your due diligence. If you don't get it, then you can now refer it back to me. Okay, so now from here, you can simplify this further. How do we do that? Take this minus out. Then you have this equals what? Minus 2 summation y minus alpha cap minus what? Beta cap s into what? S equals to 0. So let's divide through by minus 2. If you divide through by minus 2, what do you have here? You have minus 2 summation into y minus alpha cap minus beta cap x s equals to 0 divided by minus 2 divided by s divided by 0 is what? 0. This cancel this as we have what? Summation y into what? Y alpha cap minus what? Beta cap x. So therefore now we can open this bracket. Right, we can open this bracket. Don't forget we have x here. Right? We can open this bracket. So multiply all through by x first. So you have summation into what? Xy minus what? Alpha cap x minus what? Beta cap s squared equals to what? 0. So now let's multiply all through by the what? The summation. So yeah, what we have is what is summation xy minus alpha cap summation x minus what? Beta cap summation s squared equals to 0. So all the next you do here from here is what? Is you what? You make summation sy subject of the formula. Alright, When you make summation x, y, series of the formula, what do you have? Then you have your what? Summation x, y equals to what? Equals to alpha cap summation x plus what? Beta cap summation s square. Right? Alpha cap summation s plus beta cap summation s square. This comes to the right hand side. So the changing sign from minus to plus. So this is your second normal equation. Normal equation. Alright? This is your second normal equation. You can call this what? Equation 8. You can call this equation 8. Now that you have gotten your normal equations, it is from these normal equations that you are now going to what? Apply what? Knowledge of metrics, that is apply Cramer's rule. Now, with Cramer's rule now, these normal equations, you are going to derive your what? The formula for what? For estimating the parameters of what? Of an econometrics model using ordinary least square. Simple linear regression. That's what we focus here in this word particular video. So let's not be too verbose here. Let's not waste our time with so many words. Let's get right into it. All right. What's next we are doing? We have the normal equation. What's next are we doing? All right. Now from here, these are two normal equations. So let's do a little recap of Cramer's rule. Don't forget, when you have a matrix, you have simultaneous equation in Cramer's rule. So the Cramer's rule is just you have your x equals to what? H. Alright? As equals to H. Where here we are talking about the words, the parameter, that is the coefficient of the variables that we are trying to estimate. Why x here connotes the variable we are trying to estimate, and the H here is the what? Is the constant, the matrix of the what? Or the constant. So you can, from here, if you apply this to this is what we have here. Our A here, this will be what? Here we are trying to estimate alpha and beta. So our A here will be coefficient of what? Alpha and beta. So what's the coefficient of alpha here? You have n, you have what? Summation x. What's the coefficient of beta? We have what? Summation x and what? Summation s square. This matrix. What will be our x times what? Which are the variable we are trying to estimate, which is alpha cap and what? Beta cap. Okay? And the constants. This is what? Summation y and summation x y. Okay? If you are applying Cramer's rule, this is what this turns out to be. So now, how do we now find your alpha cap and beta cap using Cramer's rule? The formula is still very simple. Using Cramer's rule, so our alpha cap will then be equals to what? The determinant of what is of alpha all over what? Determinant of what? Of our coefficient. That is this is the general determinant. Y beta cap, our beta cap will then go determinant of what? Of beta all over what? The general determinant. The general determinant. This is beta. So this is how you find that. Now, of importance is what? What is our alpha matrix? Okay. Still from here, what is our alpha matrix? Our alpha matrix, we already find our general determinant, which is A matrix, to be equivalent to what? The matrix of what? N summation x, summation x, summation s squared, which is this. Now, the next thing we have to find is what is what? Alpha matrix. So alpha matrix, don't forget, this is the coefficient of what? Of our alpha. So to find our alpha matrix, you replace the coefficient of your alpha matrix by the what? By the constant. So you delete this and you bring this. So you change the entire column. Alright. So our alpha matrix will now be what? The matrix of what? Summation y, summation sy. So we put this by, which is what? Summation x, summation s squared. So we do the same thing for the what? Beta matrix. Okay? Do the same thing for the beta matrix. Your beta matrix is just, these are the coefficient of your beta. So you replace it by the what? By the constant. Which is now then equals to what? This now then equals to what? Summation, this be n, summation s, then you have summation y, summation s, y. This is the general matrix, this is the alpha matrix, and this is the beta matrix. So from here, what you need is the knowledge of what? Determinant. Okay? Knowledge of determinant. Alright, our determinant of A, which will now be determinant of what? N, summation x, summation s, summation s square. Is the same thing as multiplying the principal diagonal, then subtract it. The product of the principal diagonal and the product of the minor diagonal, they subtract the product of the minor diagonal from the product of the what? Principal diagonal. What am I saying in that long set of words? It's just that you have this multiply, which will give you what? N summation s square, while you subtract the product of which is what? Summation x, summation x. Alright, this is what? Determinant of this. Okay? So what's determinant of what? Of alpha? This is what? This times this minus, which is what? Summation y. Okay? Summation y, summation s square, minus what? Summation x, summation s, y. Don't forget, this multiplication is what? Is commutative. Either way you arrange this, either way the one you put forth, is still the same thing. A times B is the same thing as B times A. Alright? It's commutative. So what is determinant of what? Of beta. Alright? So the determinant of beta will then be what? N summation sy minus what? Summation what? X summation y. Alright? Now we've gotten this, we've gotten this, we've gotten this. So all we are left to do is to substitute this and find what is our alpha cap and what is our beta cap. Alright, so here our alpha cap or alpha estimate will then be what? Summation y, summation s square minus what? Summation x, summation sy, all divided by what? N summation s square minus summation x, summation s theta, summation s all square minus summation s all square. Right, you can call this what? Equation 9. Y beta cap equals to this, which is n summation sy minus summation x, summation y, all over n summation s square minus summation s all square. I call this equation 10. So equation 9 and 10 here, this gives us the formula we use in estimating our parameter of what? Econometrics analysis using what? Absolute approach. Right? Using absolute approach, this is the formula for our alpha and this is the formula for our beta. Alright, suppose if you refer back to the previous basic econometrics model that we use, right? The basic econometrics model that we use, we said we are given a model such that y equals to alpha plus beta x plus u, which is our what? Error terms. And we said our y cap equals to alpha cap plus what? Beta cap x. So now, from here, this is what we are given. If you apply this formula, we get what's our x cap, right? This is our beta cap x. So when we apply this formula, what we get is we get our alpha cap to be what? Let's say 2, and we have our what? Beta cap to be what? 0.5. So now our y cap, ys will now be what? 2 plus 0.5x. So now from this model now we can make what? We can make forecasting, we can make prediction, we can plan. Alright? So what this implies is that what? For every 1 unit in x, a 1% a 1 unit increase in x led to what? Is 0.5 increase in y. That's the interpretation. There is a word interpretation. Alright? Let's say this is what? 0.9. Let's say this is 0.9. It means that a 1 unit increase in S, which is the what? The independent variable, brings about 0.9 units increase in what? In Y, which is the what? The dependent variable. That's what this is all about. All right, this is what this is all about. And with this, we've come to the conclusion of what? Proving the what? The deviation, the absolute approach to solving what? Ordinary least square of a simple linear regression estimate. So what we go further to deal with now is what? Is illustrations using this what? This formula. We go further with illustrations using this formula. All right. For us not to make this video lot long, so we'll cover this in a separate video. Cover this in a separate video. So the next video you'll be watching is what? Is a certain illustration where we apply this absolute approach to what? To estimate what? An econometrics model given real life empirical what? Data, even real life what? Data, right? We'll be using that. All right. With this we come to the end of this video. All right. Feel free to like. Feel free to contact me if there's any part of this video you couldn't understand, or there is something sharp, just anything you can understand. Feel free. Just come to my DM directly. My contact is attached to this video. All right. I'm very much available. All right. Just come around and we can learn together. All right. So don't just watch this video. Like, comment, and subscribe, and as well share to your friends this video, and of importance, subscribe so that when next I make quality content like this, you'll be forced to get notified. Econometrics is simple as ABC, and on Success Enlightenment we guarantee that even the least attentive student in class can have a mastery of what? Econometrics. Till next we meet, I'm Ishola Adedeji Michael, and this is Success Enlightenment. Thank you.